question 7, we have P and Q. We want to find the midpoint of them. 2 minus 3 minus 2, 1. So we're going to add them together and divide by 2. So 2 minus 2 is 0, divided by 2 is 0. Minus 3, 1 is minus 2, divided by 2 is minus 1. And this is the point OR. So let's put these on a diagram. So let's put P on first. We've got 2 minus 3, so out 2, down 3. P. Q is minus 2, 1. Minus 2, 1. Q. And the midpoint was 0, minus 1. Midpoint was here. That was OR. So if we draw a line, and then we are asked to find the equation of the line perpendicular. So up through here, going in either direction. So we have positive slope to begin with. So we need the slope of QP and then the perpendicular slope. You can see the slope of QP is negative. So M1, the slope of PQ, is equal to negative. The change in Y is 4. And the change in X is also 4. So equals minus 1. So the slope of the other line needs to be plus 1. M2 of, we call this line, did they give it a letter name? K, they do. So the line K, the M2 of K, perpendicular M2 is equal to plus 1. So now we have a point, or we have M2 is plus 1. So into the equation of a line y minus y1 equals m times x minus x1. We're going to get y minus minus 1, so plus 1 equals m, which is also 1 times x minus 0, which we don't need, but we can put it in anyway. So we get y plus 1 is equal to x, or y is equal to x minus 1, some version of. Then we're asked to show that the point S is on K, 3, 2. Let's see, does it fit on our diagram? 3, 2, 3, 2. We're a bit off. 3, 2 looks like it's about here. But the point 3, 2 would be y2, x3. So that does work. 2 is equal to 2. Therefore, S on line. Then prove that PQS is isosceles. So we'll just redo the line to get 3, 2's on it. And then this is the point S. And PQS isosceles. So we need to show that they have two sides the same. So they have a common side here. RS is equal to RS. Let's compare the two triangles. That's a common side. So if we get the length of QS and the length of SP, so QS and SP, let's write down these points. Q is minus 2, 1, and S is 3, 2. So the length of this is equal to the square root of the change in x to b squared, which is 5, and the change in y to b squared, which is 1. Difference between 1 and 2, so root 26. So S 3, 2, and the point P 2 minus 3. The length of this line is change in x is 1 this time, and the change in y is 5, which is also root 26. So we have two sides the same. So far one of them is internal, but we have root 26 and root 26, and what we did at the start was we found the midpoint. So this length has to be equal to this length. I'll put 3 lines. So we could say SQ is equal to SP, both root 26, you could say, by Pythagoras. And then we have QR is equal to QP. We found that to be the midpoint. So two sides the same. Therefore, they have to be isosceles.